I am Hardik Pandya. You have heard the name Hardik Pandya, a cricketer? No. So, I am a professor uh, in the Department of Electronic Systems Engineering at the Indian Institute of Science, Bangalore. And previously I have taken few courses in NPTEL. I think this is my 5th course, and this course is focused on sensors and actuators, is design and characterization. All right. So, very interesting course where you will be taught what are the basics behind sensors, actuators. When I say basics, that means what is the physics that rules this particular device, right. What is the phenomenon, what are the phenomenon that we need to understand for fabricating an actuator or a sensor. Then very interesting problem is how you will design a sensor or what kind of sensors you need to design for applications in medical domain or in a space domain or in electronics domain, right. So, once you understand how you can fabricate sensors, how you can fabricate actuators, you can think about an actual problem where you will be using those sensors and actuators to design a system. And when we talk about system, it is an electronic systems, right. So, it is very interesting course, like I said, and what you will be taught. So, you will be taught how a silicon wafer looks like. From silicon wafer, we start with silicon wafer and we end up in a sensor. That means all the process that are required right from silicon wafer to the sensor fabrication, you will be taught here. Whether it is growing a thermal oxide as an insulator or depositing metal using thermal evaporation, e-beam evaporation, sputtering, which are physical vapor depositions, or growing insulator using CVD, which is chemical vapor deposition technique, or photolithography, right. So, everything, when I say or, does not mean or, it means that everything that are every technique that is used in fabricating sensor actuators will be taught. I will try to cover it in this particular course. All right. Now, when you talk about sensors, when you talk about actuators, right, where you will be using it. So, how about we learn some of the techniques which will help us to design a microfluidic platform. So, we will talk about microfluidic devices and how these devices would be helpful. For example, if I give you 4 different drugs, right, and I ask that which drug would be more effective for the patient that has come to the hospital. Out of 4 drugs, which drugs you will select, right, for drug 1, 2, 3 or 4, you have no idea, right, and unfortunately we do not have any idea of which drug would be effective for that given patient. That means we do not have a patient centric platform, right. So, what if I say that you can now design a microfluidic platform with electrical sensors to tell that which drug you have to give for a particular patient coming to the hospital. That means you are designing a drug screening tool, right. This is just an example, okay guys. So, now how about this thing, how our nose works, do you know, right. If I want to fabricate a sensor or array of sensors which will mimic similar to our nose, what is the technique? You will learn these things, all right. And then characterization techniques, characterization techniques are several. For example, SEM, scanning electron microscopy, TEM, transmission electron microscopy, XRD, X-ray diffractogram, right, EDX, energy dispersive X-ray, right, AFM, atomic force microscopy, and lot of other characterization techniques are there. You need to understand how you are taking out the context, you need to understand how to simulate the device. We will have a separate session on simulation, right, based on COMSOL multiphysics. So, if you fabricate a device, before fabricating a device you need to understand how the device would perform if your fabrication steps are correct, right, the process is correct, the recipe is correct. So, you have to perform a simulation, right. Then one of the component for this particular program or particular course is a lab component where I will take you to the laboratory and will show it to you what kind of equipment are there that can be used to characterize or fabricate your sensors and actuators, right. What kind of laboratory you require? Is it a similar laboratory that you are working for your electronic experiment or other experiments, or you require a laboratory which is much more cleaner than that particular lab that you are working in? When I say you are not working in a lab which is not clean, I mean that your lab is clean, but we are talking about clean room, class 10, class 100, class 1000, class 10,000, right. So, what kind of clean room environment you require for, or you will require for fabricating such sensors or actuators. So, we will be talking about that. We will not only restrict ourselves to how the deposition technique works, but we will also see some of the deposition techniques in a real time. What does that mean? That I will show you equipment in the clean room that you can use to deposit a metal or an insulator, alright. It is called electron beam evaporator. So, my idea here is that not only to talk about theory, but also to take you to the laboratory and show you what kind of techniques are used for fabricating your sensor and actuators. Alright. So, I am sure that this you will like this course. There are lot of applications of sensors. We will be talking about lot of sensors, and we will be talking about MEMS based sensors, which is micro electromechanical systems based sensors. We will talk about actuators, which is the piezo actuators. We will talk about piezo resistive sensors. We talk about micro cantilever, right, pressure sensors, force sensors, how it can be used in medical domain. If you talk about atrial fibrillation, how it can be used for electronic nose, right, how it can use for drug screening, and lot of applications, right. Once you understand how to design and fabricate a sensor, you can work on several research problems simultaneously, right. So, the heart of electronic system or a medical device is most of the time the sensors and actuators, and we will be understanding how to design those, how to fabricate those, how to simulate those. Alright. So, if you are interested, register in this NPTEL program. I felt that this program is excellent because it is like free, right. You do not have to pay anything, right. Education should be free. So, through NPTEL platform, the education is now free for all, right, with equal opportunity, right. You can sit at home and learn. What else you want, right. Only thing is, if you like it, if you understand it, if you go through assignments, homework, if you are confident, right, only a small payment that you require is for appearing in the exam, that is it, right, you get a certificate. So, for me it is a very interesting concept of using this beautiful NPTEL platform and to register and to learn several courses, right. This is one of the course that I will be talking about, but there are several courses. You can go through the NPTEL website and look at the interesting courses, right. If you are interested in this course, register it, and we will go through around 30 hours, right, to understand several sensors, actuators, its design and characterization. Alright. So, till then, all of you take care, right, have fun. Learning is always a fun, not a burden, right. So, remember that when you learn new things, when you educate yourself, right, it should make you happier, right. If it burdens you, there is something wrong, right. So, we will go through the 30 hours and I will keep in touch with you through NPTEL platform, NPTEL forum. We have a live sessions. So, through that you can ask me if you have any doubts, right, and we have few assignments and homeworks which every course would have, right. Alright, then I will catch you later once you register. Till then, you take care, have fun,